Thank you very much for the technical professionals here. So can I start? Okay. So with a quick raise of hand, who here has been to the great Kafka talk by the eBay folks? Okay, good. So I see there's a lot of Kafka enthusiasm today. That's great. So welcome, everyone. My name is Natan Silnitsky, and I'm a backend infrastructure developer at Wix.com. And this talk is about the ecosystem that Wix has developed on top of event-driven architecture with Kafka. And I want to share with you the best practices, SDKs, and tools that we have developed in order to be able to scale our event-driven system and distributed system for more than 1,000 microservices. So you may be wondering what is Wix? So Wix is a website building and business management platform where basically you can create stunning websites completely automatically, or you can also drag some template you like and customize it with the drag and drop visual editor. And also you can add many code snippets in JavaScript and customize it to whatever you fancy. So it actually is a huge set of products and services that we offer. And specifically with Wix backend, a few numbers. We have around 270 developers and more than 1,300 microservices, and over 10 million lines of code in Scala, Java, and Node.js. Well, mostly in Scala, but there is considerable Java and Node.js code. And we have roughly 850 million Kafka messages every single day. So, like I said, I want to share the Interservice communication story and how Wix has evolved to the event-driven architecture design. So, back in 2014, we started off with RPC, synchronous RPC, and it was on top of JSON protocol made in-house for Java and Scala, and you can have very limited fault tolerance where if you get an error in your request, you can try it again. And for very special cases where you wanted complete fault tolerance and scheduled retries, we used ActiveMQ, if you remember good old ActiveMQ, and built on top of it the retry mechanisms. And we really like the fact that we can use the embedded JMS broker of ActiveMQ for the JVM. It was back in the pre-dawn of Docker days, so it was very important for our integration test to have this feature. And with Wix really like making sure that we are completely covered by tests. But we suffered from a lot of production issues with ActiveMQ, and we weren't really pleased with this solution. So in 2015, we started looking at the Kafka SDK as an improvement to ActiveMQ. And we noticed that the SDK itself has a lot of boilerplate and missing features. So we decided to wrap the client Kafka SDK with our own wrapper and called it Greyhound, which made the life of our developers easier because it's a simpler API with a higher level of abstraction. And just to complete the picture, in 2018, we moved from RPC to asynchronous request reply model with gRPC. For those of you who don't know, gRPC is Google Remote Procedure Call, which takes advantage of HTTP2 protocol and streaming. And for us at Wix is also allowed to switch to a more polyglot nature of our microservices with introducing Node.js-based services and be able to communicate between the different services with gRPC. So basically, we have a hybrid module of some request reply and a lot of event-driven messaging. So with the help of Greyhound, we could easily scale up Wix in the last few years to a lot of microservices, like I said, and easily change behind the scenes the infrastructure on top of Kafka, which I will describe shortly, and really ease our development velocity and make getting to production faster and bigger. So, like you see here, our scale has grown. So, the reason we chose Kafka is that it really suits us. So, with a raise of hand, who here has good familiarity with the way Kafka works? Okay, good. So I see some of you are familiar and some of you less. So let's talk a little bit about how Kafka works. So basically, it's a messaging broker, and you have producers and consumers. You produce the messages to topics. Topics are divided into partitions. So when a producer produces a message, it goes into a single partition. And the partition is basically an append-only log where you keep getting new messages appended. And you can theoretically never delete any message, while the default time for keeping messages in Kafka is 1 week. So it's different than with traditional messaging queues. Now here, the Kafka consumers from different consumer groups can read these messages sequentially from this partition, and each of them in their own pace. And notice that they don't remove the message from some queue. They just go over them sequentially. So that's the key difference between Kafka and traditional messaging queues. And this paradigm of using append-only sequential processing by partitions means it's extremely performant. It gives you high performance. Most of the consumption can be from the Kafka brokers in memory, so you usually don't even need to go to disk. And the sequential nature means really fast processing. And also the division to partitions means that you can really scale up into crazy amounts, like we heard in the eBay marketplace scenario of 1.5 trillion messages per day. So that's definitely something Kafka clusters can handle. And you basically just add more partitions and more clusters as you need. So, like I said, we decided to wrap the Kafka SDK, and we're going to talk about a little bit why we needed it. So, why should you wrap a perfectly good SDK, right? So, let's see. The first thing is set up boilerplate. So, Kafka Client SDK has quite a lot of boilerplate that you need to set up. So you need to set up all of these properties if you want to get a properly tuned producer, for instance. And one of the things that you need to set up is how to discover where the broker location is, what's its address, among many other things. And with the Greyhound producer builder, it's much more simpler. You get fluent design, and it's behind the scenes. It will give you the auto discovery of where the broker can be found, for instance. Now, it's the same story with the Kafka Consumer. it also has to specify a lot of properties. And one interesting one is about serialization. So you can decide that you're only going to work with strings, and then you specify string serializer, or you decide that you want to work with higher level types. So then you're going to have to create your own custom type serializers and deserializers. So with Greyhound, basically, it's very opinionated, and it wants the developers to use types, and it just works behind the scenes with Jackson, so you can have JSON serialization or Proto serialization, and you just submit a handler, which I'll show in a minute, what is made of, which works on a specific type. So we talked about setup boilerplate, but also the consumer API with Kafka has a bit of boilerplate as well. So we created a Kafka consumer, and now we're probably going to have like an infinite while loop where we're going to decide how many messages we're going to poll, and then we're going to process each messages one by one. And of course, at the end, we need to decide when to commit the message, because only once messages are committed, then you can be certain that you won't be retrying them in the future. Again, it's different than how messaging queues work. So you can also decide to do automatic committing with Kafka, but then you may end up losing, not handling the messages in certain situations, so it's more reliant to commit yourself. So there's quite a lot of things to do here. And with the Greyhound consumer that Wix has developed, you simply provide the Lambda. You provide the message handler with some specific message, some specific type, excuse me. And that's pretty much it. So you don't have to work with the committing, think about committing, and all that is taken care of for you. And we'll see a little bit about that in a little while. Okay, so let's talk about other missing features of the Kafka SDK. So this quote is from the official Kafka documentation, where it says the Kafka consumer is not thread safe. So if you want to have multiple threads accessing the same messages from the same partition and create and then process them, you will have to create your own synchronization code to do that. And anyone who worked with multi-threaded code before knows that it's really hard to get it without any bugs. And you don't want it to keep doing that again and again. So maybe another way to go through this is just to create more Kafka consumers, but then you end up using more resources than you want. So the approach that Wix took is just to have the Greyhound consumer offer the user to decide what's the degree of parallelism that he wants these Lambda functions to operate on in parallel. So it just has a simple worker thread pool behind the scenes, which processes the messages from the partitions, and it needs to, of course, the topic needs to have at least amount of partitions as you decide the amount of parallelism. So behind the scene, it will use the Kafka SDK, fetch the messages, distribute them to worker threads, and handle exactly when it needs to be committed. And that's basically it. And like you can see with the very simple, fluent language, you declare the amount of parallelism you need. Okay, so that was about parallel consumption. What about error handling? So like Gregory mentioned in their talk before, you need to implement retries yourself. Kafka does not deliver that. So basically with the Greyhound consumer, you just specify a retry policy, and you declare how many steps you want to retry upon, and what's the interval for each retry step, 1 second, 10 minutes, etc. And basically, this is implemented in a similar fashion to what was mentioned in the previous talk, where for each of the retry steps, we create an additional topic behind the scenes, a retry topic, and then you have, if the handler that you provided has throws some exception, that means that the going to be a retry producer that's going to send the message to the retry topic at the time that you defined when you defined your consumer retry policy. Now, that's not the optimal solution, but really there's no silver bullet when it comes to Kafka retries. You can have alternative ways to do it, but none of them will be optimal. In this case, the solution works, but it will require many more topics, meaning many more partitions. And a very important fact that you should know about Kafka brokers is that for a single Kafka broker, you don't want to have a limitless amount of partitions. The optimal amount is usually up to 3,000 partitions. So as you grow your scale and you have retry topics for a lot of your topics, it means that you'll probably need a lot more brokers as well. So that's something that you need to keep in mind when you define retry policies. Okay, so the next feature is blocking policy. Why do we want to block execution? Well, with this solution for retry scheduling, you will get out-of-order processing, because once the message is moved from the original topic to a retry topic, you can definitely get a situation where a new message will be processed before the older message will get processed in the retry topic. So we just offer a blocking policy that just means that if the handler throws an exception, then you will retry the same message on the failure again and again according to the policy that you define. And this situation, of course, can result in lags. Lags means that we have the producer producing messages faster than the consumer can handle them because he's stuck on some message that he can't finish. But this is actually a great feature of Kafka, where messages don't get lost, they just get delayed processing. Now, we have a back office for that at Wix, where developer got an alert that the lag has increased or something like that, and then they can decide whether to release the block because the error is not really interesting, and then the lag will be reduced. Or what they can decide is they see that they inspect the message content and they see, oh, we have a bug here that we need to fix. So they just fix the bugs, release a new version, deploy a new version, and then with the help of Kafka, the consumer will just pick up from the last from the last uncommitted message that I mentioned before, and hopefully the lag will go away in a short period of time because the bug was fixed. So we give, other than the SDKs that we have created, we also give back office tools for production handling, and this is one use case where you want to give control for the developers to be able to, it can still be relaxed because the messages are all in Kafka, nothing is lost, but you still want them to have the power to decide, am I going to release this blockage or I'm going to fix a bug, the power is in their hands. Okay, another interesting feature that we have is the resilient producer. So even though once a message hits Kafka, it's persisted and it will never be lost, you still have times where the Kafka brokers are unavailable. It happens, and then you can't get your messages through. So for these kinds of scenarios, you can use the resilient producer. So once you use the resilient producer, messages always are first saved to disk. In this implementation, it's simple H2 database file where messages are first brought in there, and then it tries to be produced to Kafka, and it will retry upon failures for as much as it needs. Now, this scenario of using resilient producer, it's not intended for all use cases, of course. First of all, a lot of the times you first consume the message and then produce to another topic. In that case, this feature is pointless because the message is already in Kafka. Why introduce a new failure point? But if you have some scenarios where you want to first introduce event-driven flow and there's no user waiting in the browser, then you can definitely use such a resilient producer, because it will mean that you will not only be guaranteed message processing in Kafka, but also guaranteed that the messages arrive in Kafka in the first place. And it comes in two flavors, either ordered or unordered. Basically, with ordered means that it will block until the message is produced, and unordered will give you better throughput because it doesn't block, it just tries to produce the message and won't get persisted. If there's some failure in H2 database file, then it will just bypass it. So on the one hand, it's unordered execution, but you do get better resiliency and throughput. Okay, so something very important for us at Wix that Greyhound offers is context propagation. So for almost any company, it's important to know who initiated some request when it travels throughout all the microservices in your system. And for Wix, the decision was to gather quite a lot of details about the user throughout the request lifespan in the system. And what Greyhound simply offers here is a way to keep this propagation flowing even through the event publication and subscription design and event-driven design. So basically, it will just take the user data and stuff it into the Kafka headers seamlessly behind the scenes, and then let the consumer pick it up, and then you are able to use this information without needing to do any extra work. So it's very similar to having a request with RPC with the user data baked in. And last but not least, very, very important feature, crucial really for real proper operation with distributed system on a large scale in production is, of course, matrix publishing. So Greyhound offers a lot of publishing behind the scenes of matrix to start the server. So both the producer and the consumer will produce these messages, and you'll be how many messages are produced or consumed at certain points for each topic and group, and how much time it took to process one message, error notifications, lags, and all of these. Then we add upon it automatic alerts in Grafana And by the way, we also have automatic, this dashboard automatically is being created for each new microservice that is added, so the developer doesn't need to recreate these dashboards again and again. And then the auto alerts gives notification for the developer that something happened in Slack or email, and they can address that promptly. Okay, so we talked about the Greyhound features, why we wrapped the Kafka SDK to get it more simple, to have higher level abstractions with using just your letting the business code be the key here and not all the boilerplate around, and all the missing features for producing, consuming, and behind the scenes tracing and matrix publishing. So Greyhound takes care of the mechanics of distributed systems, so you can focus on writing business logic. And we are planning to open source it very soon. We also include a test kit where it raises up Kafka brokers and Zookeeper, and then you can auto-discover them behind the scenes, and also provides message syncs, so you can, in an integration test, learn whether your messages were produced successfully, etc. So we're very excited about that. And for us at Wix, we have a continuous integration pipeline built on top of the Bazel build tool, where all dependencies keep getting updated from source. So that means that you never have to decide when to upgrade to a new version of your dependency. It always gets updated. So all of the microservices continuously get new features of Greyhound and new bug fixes, so we have more resiliency and faster delivery of new features and new capabilities to production. So let's switch gears now and talk about the user flows of our the communication and the user flow architecture at Wix. So like I mentioned before, it's basically a hybrid solution. So some of the communication is done with request response style. Of course, everything that is incoming from the browser, but also some inter-service communication is done with the gRPC. But also, of course, a lot is done in the event-driven style with the help of Kafka. So, for instance, the classic use case is, of course, publish, subscribe, the classic one, where you want to have opposite direction of request reply. You don't want to get bombardments, like they mentioned in the previous talk, for some legacy database. So you just want to publish to the world that, for instance, in Wix, a site was created, and then you'll have a lot of consumers that needs to do a lot of stuff in their own time, in their own way. And so you decouple it, and you get better throughput and better scalability, of course. So that's the classic key advantage of PubSub. Another interesting use case is without inter-service communication, but if you have just your one service that you want to make sure that the action will get executed. So why not use Kafka, right? You have some job scheduler that notifies you that the subscription needs to be renewed. So you just produce this request to Kafka, and then using the Kafka persistence that you know that this request is not going anywhere, and using consumer retries, you can make sure that this request will be handled and the subscription will be renewed. And one last use case that I find very interesting as your scale and complexity of your business grows is having long-running async business processes. So really the request response module is not really necessary these days when you have WebSockets and stuff like that. So basically you have, in such a scenario where you're going to use WebSockets, the browser will first subscribe to notifications from the WebSocket service we have at Wix, and then you start some complex business process using Kafka. So one example could be importing contacts from Google for a Wix user when he manages contacts for his website. So that can take a long time, but really there's no point not having this in a completely async, event-driven way. But you still need to return a response to the browser. So once all this processing is done, at the end of the road, you just signal the WebSocket service, hey, here's the complete response, and it will send it back to the browser. And once more, we have a solution in place for CrossDC at Wix. So this Kafka message can be replicated across DCs. So the processing can be done halfway across the world, but still eventually will end up in the correct browser for the correct user with the power of WebSockets and Kafka. Now, of course, with Kafka, you also have the ability to store, and the previous talk dealt with this quite a lot. So we also have features for key value stores that we've created at Wix, but this on top of Kafka. But this is out of the scope for this talk. So if you're interested in more about how we did this without Kafka streams, you're welcome to talk to me after this talk. And we also implemented our own CrossDC replication solution. Basically, we call it Raven, and it simply has a dynamic consumer with a lot of partitions inside that just consumes a message and then produces it to the topic on the different data center. And the reason that we needed to implement it ourselves and not use the mirror maker that was mentioned in the previous talk is that the semantics were a little off for us about how you specify topics and stuff like that. So we just wanted to have a seamless experience for our developers. So it's really easy for them to set up in the back office. And the use case may be that you have production of messages only in one data center, but all data centers need to be consumers. And of course, with key value stores, you also want to make sure that the data is kept in all of the data centers. And of course, it's better to be used in an active-passive fashion, because I wouldn't recommend using it in an active-active kind of topology. And we also have created a back office for managing all of Greyhound and Kafka. So for instance, the user can decide to raise the amount of partitions for some topic, and also they can see the updates, real-time updates for the key value stores or just for a regular topic, and understand who consumed the message, which service consumed it. Because remember, we're talking about distributed topology of many microservices, and it can be really difficult to understand what's going on in such a scenario. So these tools are quite valuable. And of course, we also plan on open sourcing this back office tool, because basically everything is intertwined together. And Wix has embraced Kafka for large-scale and asynchronous event-driven design, but we also understood that you require a lot of tooling in place to support it. You need to have the correct monitoring and production, the correct actions that you allow your developers to take in order to maximize it. Because yes, you get high throughput, high scalability, but you also get potentially a lot more complexity and blindness about what's going on in production. So it's very important that you have the right tools in place to offer the production monitoring and fault tolerance with retries and a way to resolve issues that will happen. We all know that production is not a perfect place, so you really want these tools in place. So that's what we've learned, and that's what we created. So thank you very much. And you can find all the slides and links in SlideShare in this link right here. And you can also follow me on Medium and Twitter if you want to get updates on Kafka and also our CI. And I'm ready to get your questions if you want. Yes.
Yeah. Hi. Do you hear me? Okay. Hi. Thank you for this talk.
Sure.
Just like a couple of quick questions. So, first one, you say that the Greyhound was designed to reduce the boilerplate code.
Right.
And this is something that I was really surprised, just because the example of settings that you just showed on the first slide was exactly the default settings for Kafka, which is completely designed to be as aligned to your message load as possible. So there's something that's really important. So my question is, it's just because of like a Wix concerns that everything just goes default settings, or Greyhound is able to work with that?
Okay, so it's a good question. So I think the default settings can help you some of the time, but I don't think that for a lot of them that it usually works. So for instance, the auto commit that I mentioned, sometimes you won't want to use it, and you want to have a finer control about when to commit on how many messages you want to commit after, etc. And we saw that just encapsulating this code for us worked better, and you can change it if you want from the Greyhound setup. But just because we have a higher level abstraction than where we invoke these handlers, and we know the best optimal time to commit messages. That's one example. Another example is about serializations and deserializers. So if you want to work with types, so Kafka doesn't offer something out of the box, and you have to configure it. So I'm not saying all of the configurations from Kafka you need to tweak, but a lot of them we felt that if we took it to a level above and tweak them, it can really help our developers, and you don't need to re-implement it each time and just leave this in the library level. So I hope that helped.
Thank you. I have just like two more very quickly.
Okay.
So
we have the time. So it's okay.
Yeah, I will be as fast as possible. So the second one, there was like a separate slide where you mentioned that Kafka Consumer is not thread safe. Well, it's intentionally designed not to be thread safe just because of Kafka internals and Kafka architecture approach. And there was a lot of slides where you just like trying to not to shoot in the gun with Kafka. So my initial question is, are you guys like selecting other frameworks like messages after your initial problem with ActiveMQ, like I don't know, Amazon SQS or like Kinesis for streaming?
So I'm not saying that Kafka is the perfect messaging broker, or there are a lot of other options out there. These days you hear a lot of talk about Pulsar. So I don't know, maybe if we started today, we would have chosen Pulsar, I don't know. But we chose Kafka, and we are trying to make the best out of it.
Yeah, and the last question is probably not like related to this topic. So I see that you have a lot of topics, a lot of partitions. But the reality, how you monitor the Kafka lag? Is that like a Kafka manager or Borrow or just Kafka CLI? Because sometimes like the official Kafka manager doesn't count it correctly when especially you have a lot of partitions. So how do you monitor or you monitor that?
So we have the Kafka dashboard in Greyhound that Kafka exposes, and we haven't really noticed any inaccuracies in the amount of partitions and leaders there, etc. So I'm not aware of that problem. So
it's not an issue actually for you guys?
No, we haven't saw that.
Okay, thank you. Thank you so much.
We all hear this phrase security by design.
What? Sorry?
Security by design.
Security
by design.
Okay.
Yeah, so how do you guys deal with sensitive information that I assume you have in your messages? And then you mentioned you have these back office operations where your DevOps or site ops are looking into those messages and decide how to release this block or keep it and fix the bug. So how do you ensure that they are not reading sensitive information, and especially in the context of the GDPR?
Right, yeah, so that's a great question. So basically at Wix, we of course adhere to the GDPR regulation, and it's the responsibility of each and every service owner to handle their own data. So they need to encrypt what needs to be encrypted, etc. And in the back office, we also have various permission levels. For instance, well, more for not going overboard and creating too many Kafka partitions. But there is the case where you may want to obfuscate some of the data that you present. So I think maybe it's a feature that we need to consider as well, and not just rely on the service owners themselves. So it's a good point.
Hey, thanks for talk. You had a slide about the long-running business process.
Yeah.
So user starts something that waits for notification,
Right.
and your client app makes a WebSocket connection.
Right.
I'm asking because we have a similar use case. Does it mean that this WebSocket server, it listens for the topic that has notifications for any user, and depending on whoever connected, then he publishing update by the WebSocket?
Can you repeat the part about the WebSocket server?
Sure. You have a WebSocket server.
Yeah.
And this WebSocket server is listening for the topic
Right.
that has all the notifications for the users, user notifications.
Right.
Then it streams the event to the browser using the WebSocket.
Right.
So user may see something on the screen. So does it mean that this WebSocket server is listening for any notification of any user, and then depending on whoever currently is connected, so then he's publishing that?
Okay, so the way it works, there's no connection between the client side and the server side. So the client side has an authentication protocol with the WebSocket service where it subscribes to a certain channel. And then on a completely different place, the server decides he has some message that he wants to produce to a certain channel. So you can either with the SDK or with Kafka topics themselves produce this message over the channel, and then the WebSocket service that knows who is subscribed to this channel would then send it over WebSockets to that client.
So do you have a separate channel per user, so the WebSocket server is only listening the channels of the users that are currently connected?
So
I mean, if
user is the end user, you mean?
Yeah, the end user, yeah.
So I think that there are channels a channel per end user. I'm not really sure about the optimizations that they created inside the WebSocket service, but I know that it has very high scale, so I'm sure they optimize the situation where they don't, I don't know, save a lot of information per channel and stuff like that. But we can discuss later if you want more details. I happily find out and give it to you.
Thank you.
Hello, thank you for the nice speech. What's the planned date for release to public, to outsource?
You mean the date?
Yeah, just planned date, like.
So we don't have a concrete date, but we are working on it right now. It's one of our highest priorities. So I don't want to give a date and then it will miss it. But you can follow me on. You can follow me here, and you will. I will definitely announce when we have a concrete date. I will definitely announce it.
Okay, just half a year, couple of months, just.
Well, the plan is to. It shouldn't take more than a couple of months, but I really don't want. I really don't want to commit. Okay, so thank you very much for coming. Thank you.